All right, congratulations. You made it to day 4 of Properties of Exponents, our last day of notes. You're going to learn your last rules today that we'll have to keep straight. And you'll see it's going to get very interesting as we put all these rules together. Well, we learned yesterday that we learned that power to power rule, right? And we learned that this problem right here means 6x times 6x times 6x. And so 6 times 6 times 6 is what we have here. So 6 to the third power is 216, and then x times x times x is x to the third. Now, when it comes to the quiz on Friday, remember there's no calculators allowed. So on that, you could write 6 to the third, x to the third. Okay, so that could be your answer, or this could be your answer. If you can calculate it, if it's like 2s or 3s to, up to the fourth power, that you should be able to do. But anything really big, you can just leave as an exponent. So 3 to the fourth, we can do this. So remember, this means negative 3y times negative 3y times negative 3y times negative 3y. So negative 3 times negative 3 times negative 3 times negative 3 is positive 81. You should be able to do that. And then we would have y to the fourth. And finally, we have each of these to the fifth. Well, that's a lot to write out. We're going to have, I think we can see, we're going to have 5 times itself 5 times, right? So 5, oh, my pen stopped working. Give me a second here. I got to plug it in for a minute. So 5 to the fifth. Again, that we would definitely need a calculator for, or you could just leave it as the base to the exponents. Let's see if this works now. Oh, there we go. 5 to the fifth, which is 3,125, in case you were wondering. We're going to have x to the fifth, y to the 10th. So either one of these answers works. And so in other words, just like we saw yesterday, the power to power, right, that holds. In this case, 1 times 5 as well. But when it comes to that coefficient, the big number in front, that gets raised to the power. And that's where a lot of students get in trouble. Remember, this is 5 to the fifth, not 5 times 5. Okay, we have to raise that coefficient to the exponent. So here, if we start looking at these first examples here, this is 5 to the second, x to the second, or in other words, 25x squared. This one, and again, you can stop it and work ahead of me if you like. Remember, you multiply. So this is going to be 16x to the 8th. Now, if we want, either way you look at it, we could, well, let's just do it this way. This is going to be 4 to the negative 2, y to the negative 10. So we need to rewrite that as 1 over 4 squared, so 16, and then that y to the 10th. All of that moves to the denominator to become positive exponents. Anything to the 0 is 1, so this is just going to be 5 to the third, or 125. That's it. Now things are getting a little more interesting. As you can see, we've got like 2 problems here. So let's simplify this part first. So that's x to the negative 4. And then this is times 3xy squared. So now to write our final answer, we have 3. We can combine our x terms. Ooh, that's going to need to go in the denominator, because that's going to be x to the negative 3. So x to the third in the denominator. And then the y squared stays on top. Negative exponents go down to become positive. Positive exponents stay on top. This one here, simplifying that, it's going to be c to the 6th times, let's see, 3 to the 4th c to the 20th. So 3 to the 4th is 81. And then combining my c's, I'm going to get c to the 26th. Here, this is going to be, I have a calculator, so we'll do it. 6 to the 3rd, so 6 to the 3rd, m to the 3rd, n to the 3rd, distributing that 3 to each term. And then this is times 5 to the 2nd, m to the negative 6th. So now, writing our final answer, 6 to the 3rd, which is 216, times 25 is 5,400. That's the number part. And then notice my m's here. I have m cubed, m to the negative 6. That's going to give me, m to the negative 3. So this is going to be over m to the positive 3. And then it looks like I have n cubed, and that's it. There's nothing to combine with it. Now, when you have a quotient, same thing. That variable distributes to each term in the fraction. Notice it becomes a to the n over b to the n. But if that exponent is negative, remember, it's going to flip that fraction and become positive, right? Because a to the negative n over b to the negative n, if they reverse places, is going to be b to the n over a to the n and become positive. So you can just think about flipping that fraction, n becomes positive, and there you go. So let's take a look at some of these examples. So this is going to be 4 to the 3rd. Over y to the 6th. Now 4 to the 3rd is 64, so our final answer could be 64 over y to the 6th. This one is going to be 2 to the 3rd, x to the 12th over y to the 3rd. Or in other words, 8x to the 12th over y to the 3rd. Let's clean this up first. So this is going to be, let's just rewrite it first. X to the 4th over y to the 10th, z to the 2nd, now all raised to the 3rd power. So my final answer is going to be x to the 12th over y to the 30th, z to the 6th. And this one's going to be let's see, this is going to be t to the 4th over 8, all to the 2nd power, which would be t to the 8th over 8 times 8 is 64. Here's the negative ones. I know you were waiting for those. So we're going to flip the fraction and make it positive exponent, which is going to give me 5 squared over 3 squared. Same thing here. I'm going to flip the fraction, make it to the positive 4 now. So that's going to be y to the 4th over negative 2 to the 4th is positive 16 x to the 4th. This is going to flip and become positive 1, which we don't need. This is going to flip to the positive 2 now. So that's going to be 3/2 times 9y squared over 4x squared. And then we can combine. So final answer, 27y squared over 8x squared. And this one is just going to flip and be positive. That's it. All right, so now we've got some mixed practice, some mixed fun. So I'm just going to do these using our product and quotient rules. So when I'm going to make my fraction bar depending on where things go. So x is 2 minus the invisible 1 is 1. So I have 1x. For my y's, -1 minus 4 is -5. So y to the 5th in the denominator. Z is 4 minus -3, 4 minus -3, which is +7, so z positive 7. This one, remember we need to simplify the big numbers. So that's 2 when we divide top and bottom by 3. And then 2 minus 4 is negative 2, so x squared in the denominator. Or you could think cancel out, right? 2 cancels with 2 there. Oh, these are fun now. So these are fill in the box. See how there's like the empty box there? So it's saying what minus 4 equals 2? Well, I think that empty box is equal to 6. 6 minus 4 is 2. Here's the empty box right there. So when it comes to B, whatever that box is, 4 times the box has to equal 12 when we look at the exponents, right? That's going to distribute, and it has to equal the 12. So it looks like box is 3. Here, notice for the m's, 3 times the box has to equal negative 6 because now it's in the denominator. So it looks like box is negative 2. Here, 3 times the box equals 15. So box is 5. If we look at just the A's, see how the 2 and then becomes negative 4? So 2 times box equals negative 4. So box is negative 2. Here we're adding the exponents. So 7 plus box equals 4. Looks like box is negative 3. And here 2 times box equals negative 6. Box equals negative 3. Finally, we're going to apply some of our rules here to some geometry. Remember, the area of a rectangle is length times width or base times height. So this would be x squared times 5x, which would be 5x cubed. Area of a triangle is 1/2 base times height. So this is going to be 1/2 times the base, which is 4x cubed y squared, times xy. Well, we need to clean this up a bit. So this is going to be 1/2 times, now when we square all that, it's going to be 16x to the 6th, y to the 2nd, times xy. And so let's see, canceling that, we're going to get 8. Combining our x's, 6 plus the invisible 1 is 7. Combining my y's, 2 plus the invisible 1 is 3. And there we go. And that's it. Tomorrow we'll be reviewing all of these concepts in preparation for our quiz.